We are going to get started with this session. And so I'd like to introduce Dr. Cheng-Fu Chiu, who is our first speaker. Take it away.
Yes, hello everyone.
We can hear and see you. Please go ahead.
Yes, oh, thank you, but I'm not quite sure the PPT file is on the screen or not.
No, unfortunately, we cannot see your slides.
So I'm not quite sure how can I put the PPT inside here?
Oh, thank you to our audience for your patience. There should be a small TV icon on the bottom of your screen with a red bar
TV
through it.
icon. Yeah.
Okay.
Sorry. Sorry. I'm not quite sure the system is working from this side.
All right. Do you have your PowerPoint presentation open on your computer?
Yes.
Okay, and you don't see an icon on within the backstage that looks like a little monitor with a red bar through it?
No, I can see any icon for how can I put the PPT file inside. Jesus.
All right. Well, I've put my email in the chat. If you'd like to send me your presentation, I will do my best to get it on screen. In the meantime, perhaps.
Okay.
Oh,
yes.
well,
yeah.
All right. Here we go. Thank you, everyone, for your patience.
Thank you for that. Hello, everyone. The time difference is about 12 hours between Taipei and Ottawa. So good morning and also good evening. Thank you. First of all, I would like to express my sincere congratulations to the CPES 2021 Symposium Committee, who has a very successful arrangement for such a great event. I hope you can have a first image of thinking Taiwan for smart textiles through this presentation. And next, please. The first, let me just quickly introduce the TTRI, Taiwan Textile Research Institute, and some technology developed for smart textiles. The institute was founded in 1959 and aiming at improving the competence of the textile industry in the global supply chain, especially for the small middle enterprise, who do not have too much resource to keep in R&D activity and products development. The institute have 350 colleagues work for different projects, support from the government side, and it's about 55% of the total budget, 1 billion NT dollars per year, and others from the local companies, it's about 45%. Next, please. Can I just, next, please. You might agree the smart textile is a new development area for future textiles. According to the definition of the EN-SEN, the TR 16298 standard, there are two types of the smart textiles. One has a power supply and another is based on the polymer. So here my presentation is focused on the e-textile. This is a simple diagram of the e-textile which combine electronic components and fabrics. The system can be separated into sensor, actuator, or receiver, data processing, energy resource, and internal or external communication. Of course, the system will be expected to connect to your cell phone by app software and even connect to a service provided by Wi-Fi or Bluetooth. Next, please. For consumer markets of the service provider, I would like to classify e-textile into several end use, which contain fashion garments, sportswear, outdoor wear, and special uniform like the firefighter clothing, as well as the military or police uniform, and so on. And next, please. Here, I do not mention such e-text used for medical textile. And the reason why is that's more closed system in hospital compared to other consumer markets, and more certification of products like MMD or GMP for making such products. So in my opinion, I suggest that such products can list as second priority for promoting markets. You might have a question why the e-textile market has been developed for more than 20 years, but the market size is still small compared to normal textile or garment markets. I think one of the reasons for such a question is product cost, which might be a double with this system. I will happy to see if we can have more discussion about price policy or business model of e-textile at the panel later. Next, please. Regarding the technology development of the e-textile in TDI, I do roughly make a classification of all such smart textiles into 5 different functions, including lighting, heating, sensing, motion, and communication. All these different functions or products are designed from receiver or activated signal, data analysis, action control, or feedback, and create a final result such as the LED lighting, jacket heating, vital signs monitoring, finger action, and RFID tracking, and so on. I'm going to show you some cases through this presentation, and I'll just show in the next parts. Next, please. You might agree the LED lighting designed for windproof light jacket for cycling is just an active, high value-added product rather than an e-textile, but I prefer show this case here because this is a nice design of LED yarn into a garment, which also won the IR Products Design Award in 2011. So you can see the product specification is just shown here, and a PAS 10412 standard established in 2015 by cooperation with BSI in UK can be your reference. I hope such standard can revise or become an international standard. Next, please. So the same technology of using LED chips for fabric lighting as a fashion design, which were developed into the 3rd generation products with RGB LED chips rather than a single color chip. A screen printing technology of conductive material like a silver ink, costed as an electronic circle, was developed, and the products of 20 times washes was approved. Next, please. From market trend development, the e-textile are usually expected to be used for sports, healthy, and IoT living field. Here, a fabric model with a chemical electronic painting silver yarn of detecting vital signs, such as heart rate, is developed, and washing resistance of 100 times by AATCC 135 testing was approved. This is a good solution of the fabric module design, and vital signs also transfer and show on your cell phone through a design app software. So there is a very nice market from our products, which is heartbeat bell of e-textiles used for fitness, and was developed and also transferred to a local company called Zen10 Tech, who have a sales channel to connect to the Peloton in USA, and also sold more than 2 million pieces of such products during last 3 years. Next, please. There is an interesting demand for women bra brand Waco. Their own branch office contacted TDI 2 years ago and looked for a solution for stress detection for working women who might at the menopause stage have a double stress of working for the life and facing physiological changes. So after discussing with the medical device, we did recognize that our stress and relax from different types of styles can activate our nervous system, sympathetic and parasympathetic nervous. So we work with the Waco company and use the same technology of measuring vital signs. So finally, a very soft fabric module embedded into women bra, and Waco also provide 10 warranties of their brand fans. And 1 month of the verification time, and 4 times a week, and 6 hours per time was followed. And a very nice result come from this project, and stress detection between stress and relax accuracy is about 95%. Next, please. Next, please. Sorry. For the communication function of the e-textile, a young-based RFID is about 20 centimeters long. Different from tape-based RFID was developed and can be sewn into a fabric, which is expected to be traced through dyeing and finishing process with a very harsh environment of high temperature, high pressure, or acid or alkali liquid. We did with a local manufacturer called Chiu for more than 2 years, and we are happy with the result after several manufacturing and modifications for such textiles. A mass production line of RFID yarn will settle down by this end of this year. Next, please. And during the COVID-19 and pandemic last year, the quality of the medical mask was required by FDA or CDC and evaluated according to STM standard and NS 1474. For medical gown, AMIS PV70 and CNS 14798 was standards for follow the quality testing. So we do recognize that an action of the making e-textile standard is one of the key factors for promoting such products in different end use. TDI has followed the rule of setting new standard for e-textile through a FTTS committee start from 2003. There are 8 standards developed by the FTTS committee since 2010, which was shown here and can be your reference for further standard setting in the future. As I know that the ISO TC38 working group 32, AATCC RA111, STM D13.50, IPC D70 are all pacing the different types of standard for e-textiles. Here, I would like to mention again, it is important to shorten the process timing of the standard setting, and we might have more discussion at this panel later too. In order to promote the product development by R&D project, we usually help the industry to organize special group in different developing stage. For example, in Taiwan, a fabric manufacturing group of the functional textile called TRDAI was organized in 2000, and a local outdoor group's TOZ was combined into this group in 2017 to maximize the promotion to global markets. And another technical textile group called TTTA was founded in 2010 and expect to make a technical textile cluster inside the island. So for promoting the e-textile called TSTA was organized in 2018, which accepted many companies from textile and electronic industries. In Taiwan, we can see a large enterprise are developing smart textiles as one of future developing strategies such Acray, Macro, Textile, Formosa, Far East Company Group, and so on. Next, please. Yeah, here. So in order to promote the markets for e-textiles, TSTA started to call group members to join the Computex Taipei show in 2018 and continue to attend the event every year. Also, TITAS for textile industry, TISPO for cycling industry, and Medical Taiwan for medical device industry in order to promote the e-textile industry. Next, please. Finally, I would like to mention a special case of joining the international cooperation between TTRI, work with the TSTA, and NRC, work with the IntelliFax. We start from a joint research of developing screen printing technology with a silver ink or paste used for e-textile. We do work together and check the quality of such material, which is used for electronic industry, and change familiar of such conductive material used for fabric module, particularly for solve the difficulty causing electronic signal interruption by stretching and washing the e-textile. So we are expecting to have a mass production of e-textile with such conductive material at the end of this year. So this is all my presentation. Thank you.
Wonderful. Thank you so much for your presentation, and thank you also for your patience as we struggle through so many technical issues. And I know that with the time difference, we really appreciate your participation, especially.